Hello, hi everyone. It's Hitesh here. Again, welcome to day 7 of data science class. Today, we will see small project on data science. Okay, how you can create a little bit small project within 15 to 20 minutes on the data science. We're going to see that. So, the today agenda for the topic is our comparison of the classification of algorithms in machine learning. Okay, we're going to see the classification algorithms, right? You might be know about this, which is the supervised kind of a machine learning algorithm. And inside the supervised learning method, we have a two particular specifically algorithms, which is called as regression, and second one is classification. And classification is a form of data analysis which extract the models describing the important data classes, and that models can be a classifier predicting the categorical values and class labels. Okay, that output variable which is being predicted. These are the some particular classifications. We can build actually a classification model to categorize the suppose a bank loan applications or on particular either safety basis or they are on the risk basis. So it is a most widely used actually data science task in the businesses, and the objective of classification model is to predict a target variable which is in binary, and or categorical variable which is a set of input data. Now this particular algorithms, this classification algorithm like random forest, support vector machines, k-nearest neighbor, naive bayes, what are the accuracy of this particular model we have. Okay, we will take one data set. On the basis of that particular data sets, we're going to see what is the particular scenario. Okay, there are many uh, real life use cases are there to create any kind of unique machine learning projects. And if you are still struggling like to go on which on work in which particular actual cases use cases, you can find little bit of practical machine learning things of projects. And some of the particular one of the famous project is that you can say a comparison of the classification algorithms in machine learning. Now today what we will do, we will first understand the basic nature of different algorithms. Like we have a k nearest neighbor. Okay, as you know, this k nearest neighbor, which is a knn algorithm. Okay, this particular algorithm assume that there is some kind of a similarity is present between our particular categorical variable as well as into the available categories. And this particular KNN classification, if you see, is based on the principle that any objects in nature which have a similarities tend to be a proximity to each other. Okay, that is a KNN kind of a nature. Now if you see this KNN nature having some kind of an four parts, like first only look at the data. Okay, whether that particular data if you want to classify on the basis of you are classifying some color combinations or basis of calculating the distances between the gray point on all other data points. Okay, for this particular concept, so we have a this KNN algorithms. And this KNN algorithm, if you see, it is also will going to vote on the label data. Okay, what are the label data we have been present. So for that particular purpose also we have a KNN plus algorithms. Then next particular algorithm which we have next called as a decision trees, right? So the decision trees, if you see, it is based on the concept of internal nodes and the edges. Actually here the multinomial particular type of data where your some kind of an hierarchy is present in the data sets. So when you see the decision tree classification, it is also known as classification trees, which approaches the uh, you can say partitioning the data into the proper subsets which is based on some kind of a values of input attributes. And this particular attributes, if you see, it can help you to achieve the cleanest levels of such separations which is considered in the significant in the influence on the target variable and end up at the root, closer to the root level of the tree. And the output model which is called as a tree framework, which can be used for the prediction of the new unlabeled data sets. Next, which is a very important called as a logistic regression. Now this logistic regression, if you see, you might be heard about the term called as a linear regression, right? On the basis of that particular input variable, we have a logistic regression where we have binary or binomial, multinomial, and ordinal type of data. Where this binary logistic regression, which have binary target variable and can have a you can say categories of target variables that it can be predicted by. So nature of this particular target variable and the logistic regression is that used for the predicting the categorical dependent variable using a some given set of independent variables. So it predicts the output of categorical dependent variable. Therefore the outcome must be categorical or a discrete value. You can say either take a yes or no, 0 or 1, true or false. Okay, but instead of giving the exact value as 0 and 1, it gives the probabilistic values which lie between the 0 and 1. Okay, that is called as an logistic regression, and it uses the sigmoid functions in order to predict the probabilistic values between the 0 and 1. Okay, now this we will see practically how we can implement these particular all the algorithms, and how these algorithms, what are the, you can say, accuracy, how the accuracy of these algorithms gives a very immense classifications on the basis of which we can amazingly identify the unique machine learning accuracy. And the performance of all this classification algorithm will depend upon the problem we are working on it. Okay, so we will here use collagen one social media datasets. So that particular dataset link is already provided in the description of this video. You can go and you can check the dataset there, dataset link. So let's start with our particular. Okay, we'll take a new particular session. This is called as a data science project. So create a new notebook, the Jupyter notebook. You already know how you can create a new particular notebook inside the Jupyter notebook. Now give the name as DS project. You can give any name you want. It depends upon you what project name you are giving. Now let's see. First of all, you have to import the necessary libraries in order to work with it. Okay, what are the necessary libraries you can easily import it? Now suppose I'm importing, first of all, NumPy. I'm importing NumPy. Okay, I'm importing import pandas, okay, as PD. Then I'm importing, you can say, sklearn from sklearn.model underscore selection. I have to import what from model underscore selection. What do you import always? You already know that is called as a train underscore test underscore split, right? Then again from sklearn dot, if you want to import the, you can say, decision trees, in sklearn dot tree, and then import decision trees classifier, right? Decision tree classifier. Guys, please do check on the spelling mistakes, because later one single particular spelling mistake will going to give you the false errors. Okay, next, decision tree classifier. Now after importing the decision tree classifier, what we import, we're going to import a logistic regression. Okay, so from again sklearn dot, in order to import a logistic regression, we have a one particular inner model called as linear model, and from the linear model we're going to import the what, logistic regression. Okay, we will import the logistic regression. Okay, next again from, let's import naive Bayes. So from sklearn dot naive Bayes, we have a one method called as a naive Bayes. Okay, and naive Bayes is also one kind of the algorithm which works on the basis of, means on the Bayes theorem only, and it is the probability based classification approach, where the probability of interest is not absolute probability, but the conditional probability is the important thing to note here. Okay, where the variable is independent of each other. Now from sklearn.naive underscore Bayes, you have to import the Bernoulli's distribution. So let's import the Bernoulli's. Let's import the Bernoulli's distribution and give the spelling, proper spelling, guys. And it should be NB, not small nb, it's a capital NB, Bernoulli's distribution. Now from sklearn dot, now from neighbors, from sklearn dot neighbors, you have to import passive aggressive classifier. So remember, passive aggressive classifier. So do check on the spelling mistake, because again I'm saying small mistake will going to give you an error. And at last, let's import from sklearn dot metrics. Definitely, you know, if you import the metrics, definitely we are importing the classification model, right? Classification report. Let's import the classification report. Right, we have imported all the necessary libraries. Now let's run this. Hopefully we should not get any kind of an error. Now, yeah, we didn't get any kind of an error now. Now let's import our data set, right? So data equal to pd dot read underscore csv. Okay, pd dot read underscore csv, and okay, no module name sklearn dot neighbors, import k neighbors classifier. Okay, let's see. Okay guys, we have to import actually, okay, passive aggressive classifier, and we have to import the k nearest neighbor. Okay, k nearest neighbor. K neighbor classifier, let's import, and we have a k nearest neighbors. Actually it's not a, oh yeah, it's neighbors, it's neighbors. Neighbors. This week, do check on the spelling mistakes again. Right, now let's import our passive classifier also from sklearn dot linear underscore model. Again we have a linear underscore model, import again passive aggressive classifier. Okay, at last let's run this. Hopefully we should not get any kind of an error. It will take time around 30 seconds to 45 seconds in order to check whether this particular library having the right spellings and everything imported or not. Okay, now let's paste our link, whatever the dataset link I have given to you. So you can paste it from I have taken from my notepad, and we can paste it here. ed.read underscore csv, and paste it here. So like in this way, let's print, and data.head, again we're going to take our only necessary particular data with us. Okay, only the first five data we're going to take. Let's see. Yeah, we got our first five data. You can see age, that is 19, 35, 26, 17 and 19. Estimated salary we have 19,000, 20,000, 43,000, 57 and 76, and purchase we have 0 value. Right, now we will going to predict the accuracy. I mean, a data set which I am using here is a social media marketing data set. Okay, so I want to analyze actually data set at this particular time, but when you are building some kind of a project, you need actually show a detailed explanation of your data. Okay, where we have to say check out the null values, then we have to check out the missing values, and so many things we have to do, ADF process and so many other process you have to do. Okay, before going into any kind of a prediction, before going any kind of an and models. Now but let's move forward to the task of comparing the performance of a classification algorithm in machine learning, where you will going to either choose only one performance evaluation metric or maybe the more than one performance metrics, but the process will remain the same. Okay, we will see how we can do that. So let's do our particular, take our two data sets and two parameters we're going to take. You already know that is called as an x and p dot array. Okay, let's put our x and p dot array. Okay, inside the array let's take the data, and data having what? Data having first of all the age which we're going to take, and estimated salary, age and estimated salary. Okay, let's put our age and estimated salary. Great, we have got our estimated salary. Put in the inside the little comma, and after that y equal to np dot array, take to the y-axis, and in y-axis we are taking the data, and data is purchased. Okay, data is purchased. Now we have taken the x and y. Let's take, you already know that we have imported our train underscore test underscore split. So let's take our data for that. Now if you'll see, let's print first x and y. So x, and let's print y. Okay, and for that let's print, let's see. Okay, np is not defined here. Let's import as numpy as np, because the standard data set which we are using here. Right, now let's run this, and after that let's run this one, and again this, let's run this one. Can you see our data got here? Now let's use x train and x test, then y train and y test. Right, now you can use train underscore test underscore split method, which we have imported from the particular data set called as a model underscore selection. Okay, train underscore test underscore split. Give out two values, that is x and y, and put this test size as, let's see, could give as a test size that is equal to, you can put test size as 0.10, which is enough, and how much test size you want to give, and the random state. You can put the random state equal to around 42. This much is enough. Now let's take first decision trees. Okay, let's start with the decision trees. Now if I want to start with a decision tree, okay, take any variable you wanted to take, decision tree, and use that decision tree classifier. This decision tree classifier, first use this one, okay, and great. Now next use the logistic regression. Let's give the logistic regression. Logistic regression having, definitely you have logistic regression, this one, import this particular thing, right, use the logistic regression. Next you have what, let's take k nearest neighbor first. K nearest neighbors, k nearest neighbors of k nearest classifier. You can take any variable name, let's give as k nearest classifier. We have a k nearest classifier here, let's use this one, okay. Yeah, using this k nearest classifier as I've already told you. Next, third, which is called as an Bernoulli, means Bernoulli you can take, Bernoulli you can take, and Bernoulli is going to give the Bernoulli MB, right, is our function called as Bernoulli MB. This one, let's take this particular function. These are inbuilt function, guys, which is provided by the sklearn library. And at last we have a passive aggressive classifier, which is going to take this one, passive aggressive classifier, right, passive aggressive classifier. Now what we will do, let's use the k nearest classifier, this one, in order to train the data. Let's use this one in order to train the data. So dot to fit, and let's train x train and y train, right. Next you can use the decision trees. If you want, you can use the decision tree here to the gap. Let's use the decision tree and decision tree dot with method, and here also same x train and y train, right. Now next you can take as a logistic regression, this one, and let's give this logistic regression also, dot fit, and let's give the again x train and y train, right. You have taken the logistic regression. Next we're going to take the passive aggressive, this one, you can take the passive aggressive dot fit, and again x train and y train, you can take the y train. Next we have to take the data. Now we've taken on this particular functions. Now let's take the data one. On this particular algorithms we're going to give the data one, and in this inside is data one, let's write classification algorithms. You can write this classification algorithms, and after that you can write the k-NN classifier, and decision tree classifier, okay. You can take logistic regression, and you can take passive aggressive classifier, passive aggressive classifier. Let's take down. Okay, at last, outer the bracket, let's use the score, and we are taking the score means we are checking the scores. What will be the score of the each particular classifier which we are taking? Okay. Now let's check our k nearest neighbor. K nearest classifier we can check. Right. Where is our k nearest classifier? This one. Let's check our k nearest classifier. And we have to check the score. So dot score method we have, and pass the x and y data, x and y parameter. Okay. Same with the decision tree. Right. Same with the decision tree. You can check the decision tree score. Where is our decision tree? Here it is our decision tree. Let's check the decision tree here. And inside the decision tree, pass this particular two parameters. Right. Now next we have called as an logistic regression. And we have logistic regression. Let's find the logistic regression. Now give it and pass this to parameter x and y. Next, what do we have? Can anyone tell me? After the logistic regression, we have left with around one algorithm called as a passive aggressive classifier. So passive aggressive classifier, use the passive aggressive classifier here, and again dot score method, use x and y. Right, we have done. Now we're going to do what? Score equal to pd dot, we have a call as a data frame because I want to get in the form of row and column, and data 1, you can say data 1, and I'm going to print the score. Yes, I'm going to print the score. Now let's see, this is running, and we have to do the error checking. Decision tree classifier object is not callable. See decision tree classifier. Okay, decision tree classifier is not, it is not callable. Okay, we haven't used the score function here. Right, I haven't used the score function here also. I haven't used the score function. You have to use the score function everywhere. Oh, now we can check it. We can go. Let's see. Guys, you can see now. This is our classification. Okay, this warning you're going to get. Okay. Now see, this is our classification: KNN, decision tree, logistic, and the passive regression classification. Okay, this is our algorithms. Now each of these algorithm having some scores on the basis of data set. You can see 0.87, 0.98, 0.64, and 0.6425. Okay, depending upon the data set which you are using, this score you are going to get it. So in this way you can check it. You can see this my classification problem. Right, first of all I've divided this particular data into the training and test, right, which you already know. Let's me explain you. Divide it into training and test data. We usually divide our training and test data, right? So after that, then I store all the classification algorithms provided by the scikit-learn here only in this respective variables which are created like decision tree, logistic regression, right? Then I use the fit method, right, in the algorithm, and at last we have created the this particular data frame. Inside the data frame, can you see classification algorithm? This one. So this is a classification algorithm, and for the score, I've used the score method. So it's giving me this score. You can see. Each time I'll run, I want to get the same score. Can you see here? 875. Now check this particular. It is 8750. Now run this. Okay. Now this is the second one, 9800. When I run this, you can say 9825. Okay, 9825. Decision tree classifier changing for each run. Okay, for each run it is changing. See, 6425. Right. So in this way, you can see how you can compare the classification algorithms in machine learning using the particular Python programming language. Okay, you can also create your own particular library, means this decision tree classification and logistic regression and KNN classifier. Okay, you can use a particular library. You can means create a different library and you can use it on your own and see what a particular library which is given by this Python scikit-learn is giving me this particular result around 0.98 accuracy, that is 98% accuracy, and your particular which you have created that particular library is giving how much accuracy. Okay, you can check like in this way. So for today, this our small live project is there which I have taken. If you wanted to learn more projects like this in a deep with the machine learning projects and deep learning projects and the time series forecasting, you can connect to and you can enroll to the Coachx.Live. Definitely they are going to guide you at the best level. So for today, thank you everyone once again. Do and subscribe our channel. Bye bye guys. Thank you.